Okay, we have a total voltage of 6 volts here, and the voltage is being split up between the LDR and the fixed resistor of 10,000 ohms. So now we want the output to be 3 volts. Okay, if the output is 3 volts, the voltage across the fixed resistor, it has to be 6 minus 3, which is also 3 volts. And we can see that the potential difference between the fixed resistor and the LDR, they are the same. So that implies that in order for the LDR to have a potential difference of 3 volts, the resistance must be the same as the fixed resistor, which is 10,000 ohm. So the answer should be C. Okay, this is a question on nuclear physics and it is out of syllabus since 2008. Okay, in this question we have a radioactive source that gives out certain radiation and is being detected by a detector here. So we have a table below showing the count rate recorded by the detector for 4 different sources. So we are asked which source emits only alpha particle. So we need to understand that alpha particle has very weak penetrating power and it is being stopped by a piece of paper. So that means if it's being stopped by a piece of paper, it will be stopped by the thin aluminum, it can be stopped by the thick lead. So the count rate for paper, thin aluminum and thick lead should be the same. And comparing to that of no barrier, we should see a massive decrease. Okay, so in this case we can see that option B is the answer. Initially there are 200 counts, and when we change it to a paper barrier, it becomes 30, and aluminum, it stays the same, lead, it stays the same. And this 30 counts per minute is actually due to the background radiation. So the answer should be B. Okay, this is a question on nuclear physics, so it is out of syllabus since 2008. Okay, we have a nucleus that is represented by this formula here, and it emits 1 alpha particle and 1 beta particle. So what is the resulting nucleus of X? So after emitting an alpha particle, the nucleon number is going to decrease by 4 and the proton number will decrease by 2. And after emitting a beta particle, the nucleon number will remain unchanged and the proton number is going to increase by 1. So the original nucleon number is 230. So it will be 230 minus 4 will be 226, and the proton number will be 91 minus 2 plus 1. So we will get 90. So looking at the options, the remaining nucleus X should be C. This is a question on nuclear physics, so it is out of syllabus since 2008. Okay, we know that the nucleon number is 242. So the nucleon number is equal to the number of protons plus neutrons. So this is 242. And the proton number is equal to 94. So the neutron number is equal to 242 minus 94. That will give us 148. So the answer should be B. This is a question on nuclear physics, so it is out of syllabus since 2008. Okay, this is a definition question, so if you were to memorize the definition of isotopes, you will realize that the definition is 2 or more nuclides which have the same number of protons but different number of neutrons. Answer D.